Hi everybody, today we're going to be talking about factoring the difference of squares and the sum of squares. So we're just continuing on with our different factoring topics. So to factor, first of all, remember, let's do a little bit of review. We always look for a GCF to see if we have one, and then we ask ourselves how many terms. And so the ones we're going to be working on today are going to be our two terms. We're going to be working on those first. And then if you have two terms, we're going to see, do we have perfect squares? And so perfect squares are going to be numbers that multiply times itself. So like, for example, 9 is a perfect square because it's 3 times 3. And 16 would be a perfect square because it's 4 times 4. 1 is a perfect square because it's 1 times 1, and so on. I will have in Blackboard posted a whole perfect square and perfect cube sheet that will help you determine whether numbers are perfect squares or not. So when we're dealing with two terms, the first ones we're doing today are going to be perfect squares. We'll get to perfect cubes later. Alright, so the other thing you have to ask yourself, if you have perfect squares, you have to have the difference of perfect squares. And by that I mean you have to have a minus. You cannot factor if you have a plus. Okay. The only thing we might be able to do if we have an addition of perfect squares is if there was a GCF we could have taken out at the beginning. So let's look at these. These are kind of quick. There's really not a method to these. Except for if I see I've got x squared minus 25, I look for a GCF. There isn't one. I've got two terms and they're perfect squares because x squared is x times x, so that makes it a perfect square. Okay, then 25 is 5 times 5, that makes it a perfect square, so that checks off. So to factor with perfect squares, make your two parentheses, split up your x squared into x times x in each parentheses. Split up your 25 into 5 and 5 in each parentheses. Now the signs for the parentheses is one is a plus and one is a minus. So really there's no calculation to this other than knowing that 25 is 5 times 5. But each parentheses gets one of each. And if you foiled this back, I'm not going to foil it and write it down, but if we foiled it back, x times x is x squared. X times negative 5 would be negative 5x. Inner times inner would be positive 5x, so those would cancel. And then last times last, 5 times negative 5 is the negative 25. Now, this next one, this sum, you can't factor the sum of squares because our rule says in factoring squares we have a sign of each, a plus and a minus. That's so we can get that subtraction sign in between x squared and 25. If I had two pluses to get a plus here, or two minuses to get a plus here between x squared and 25, I would end up with a perfect square trinomial, which would be 3 terms, not 2 terms. So you just can't factor. So the difference of two squares results when you multiply, and I don't know if you remember this or not, but when you multiply the same parentheses with just different signs in it, those are called conjugates. The sum of two squares, a and b, having no common factors, is always, sometimes, or never factorable. Never factorable over real numbers. So let's look at this next one. X squared minus 9. No GCF. I have two terms. X squared is x times x. 9 is 3 times 3. So I would take my two parentheses, and each one would have an x in it. Each one would have a 3 in it. One would be a plus one and one would be a minus. Now you can list the minus one first and then the plus one. It doesn't matter as long as you've got one of each. X squared plus 9 can't factor. Now another way to say that you can't factor is to call it prime. Okay, that's another way. Alright, so now at the bottom of this page, I'm glad they've given us a little box with some perfect squares in it. So this is a good little box to refer back to. You may want to make you a note card and put these on a note card. I will have a posted factoring page in Blackboard that you could print off if you wanted to print that off. I'll include cubes on mine as well. But here's your nice box that gives you your perfect squares all the way up to 12 and then tells you what are perfect squares as far as variables go. So if I've got this next one, I've got 49m squared minus 81n squared. So I look for greatest common factor first. Is there a number that will go into both 49 and 81? Well, I know 7 goes into 49 and doesn't go into 81. I don't have common variables in either one of these, so GCF, I do not have one. I have two terms. Are they perfect squares? And one clue that you've got perfect squares is look to the exponent on your variable. I've got an m squared and an n squared. That tells me I probably have perfect squares. And I do, because 49 is 7 times 7, 81, I find 81 over here, it's 9 times 9. So I know that I've got perfect squares, so I make my two parentheses. Now, 49 is 7 times 7, and that has an m squared with it, so my 7 will get an m. 81 is 9 times 9, and it has an n squared with it, so it gets an n times an n, and then 1 is a plus and 1 is a minus. And there it is all factored. Okay, let's look at these next ones. 32x to the 5th y squared minus 8x to the 5th. Now this one, remember to factor out the GCF first. So let's look. 8 and 32 have a common factor of 8, because 8 goes into 32 evenly. And then I see an x to the 5th, and I see another x to the 5th, so I'm going to take that out. 8x to the 5th. So let's divide that out. And so 8 goes into 32 4 times. I'm taking out the x to the 5th, so I'm left with y squared minus 8x to the 5th divided by 8x to the 5th would just be a 1. Now, my directions are going to say factor completely. Remember, that's what our directions always say when we are factoring. So I need to look in what I have in parentheses and then go through my checklist one more time. I've got no greatest common factor between 4y squared and 1. I have two terms. Are they perfect squares? 4 is 2 times 2. Y is y times y. 1 is 1 times 1. So that means that the 4y squared minus 1 can go a little bit further. So that was going to be 2y and 2y. 4 times 4 is 2 times 2. And then the 1 is 1 times 1. I have a plus in one, I have a minus in the other. And then don't forget, we took out an 8x to the 5th at the beginning. So this entire polynomial is my answer. Alright? So that's one where you're factoring completely. You're taking out a GCF and then you look at what you have left and see if you can go further. X squared minus 64x. The first thing I need to look for is a GCF. I see an x in both of those. So I'm going to take out an x. That's going to leave me an x minus 64. Now, since I took an x out of x squared, I'm left with an x in parentheses. This is not perfect squares because now my x in the parentheses is just an x to the 1. So I am done here. All I could do is take out a GCF. Even though 64 is 8 times 8, because I don't have an x squared in the parentheses, I need to leave it alone. Sometimes y'all like to take things a little bit further than they need to go, so we have to be careful. Alright, let's do another one. 49m squared minus 81n squared. That sounds familiar. We did that one already. So we did that one already. I'm going to skip over it. The 32, we did it already. I wonder why that's repeated. That's odd. Let's go down to the bottom of the page. This is a good one. I really like this one. Alright, 16x to the 4th minus 1. Again, I look for a GCF. There's not one. I have two terms. They are perfect squares because 16 is 4 times 4. X to the 4th, look over here, is x squared times x squared, right there. That 1 is 1 times 1. I have a minus between them. Always check the minus. I haven't been saying that every time, but always check to make sure there's a minus between them. So I'm going to make my two parentheses. So we said that 4 times 4 is 16. X to the 4th is x squared times x squared. 1 is 1 times 1. 1 parentheses is a plus. 1 parentheses is a minus. Now, again, we have to be sure we have factored completely. So I look at each parentheses. I'm going to check them. I have two terms. I know I can't do a GCF because I couldn't do a GCF earlier. So I have two terms. Are they perfect squares? Well, 4 is 2 times 2. 1 is still 1 times 1, and x squared is x times x. So I do have perfect squares. But now in this first parentheses, I have a plus sign between those two perfect squares. I can't factor it any further. Remember, we can't do the sum of perfect squares. But we can do the difference of perfect squares. This one has a minus in it. So I'm going to come down here and make another parentheses to go with the 4x squared minus 1. Well, 4 is 2 times 2. X squared is x times x. 1 is 1 times 1. One parentheses gets a plus, one gets a minus. Now, what do we do with the 4x squared plus 1? We just bring it down and rewrite it. 4x squared plus 1. And that goes in my final answer. So all three of these parentheses go with my final answer. That's factoring completely. You may see that again. 16 is a good number to use that. Alright, let's try this one. 81 is a good number to use for that too. B to the 4th minus 81. So I cannot take it out of GCF. I have two terms. They're perfect squares. Make my parentheses. B to the 4th is b squared times b squared. 81 is 9 times 9. One's a plus and one's a minus. Now, we have to watch again because I need to make sure that I factor completely. I look at each parentheses. I've got a b squared. I know that's a b times a b. I know that 9 is 3 times 3. So those are perfect squares, but the first parentheses has a plus in it. The second parentheses has a minus. The first parentheses can't do anything with. The second parentheses, because it has a minus, I can split b squared into b and b. 9 is 3 times 3. One's a plus and one's a minus. Bring down the b squared plus 9 because it's still part of your answer. And so there's my final answer right there. Alright, so let's do one where we're going to do a combination. This is going to be a combination with factoring completely, and it looks like this is a 4 term, so I'm going to see grouping. We always group with 4 terms, and then let's see what happens once we get our parentheses, because it looks like maybe there's going to be a difference of squares once we do that. So if you'll remember grouping, you group the first two, you group the last two. We take out a GCF from each parenthesis. So in x cubed plus 2x squared, they have a common factor of x squared. So if I divide out an x squared from x cubed, I'm going to have an x left. Plus, if I divide out an x squared from 2x squared, I'm going to have a 2 left. Okay, so I have x squared plus 2. Now, remember on factoring by grouping, if you have a minus with that next term, we're going to take a minus out. Between 9 and 18, a 9 could come out. So I'm really factoring out a negative 9. And so if I take negative 9 divided by negative 9, I'm going to have an x left over there. Negative 18 divided by negative 9 is a plus 2. And remember with grouping, at this point my parentheses needed to match. So I have x plus 2, that's my matching, and then x squared minus 9 goes together. Now, we're factoring completely, so let's look at our parentheses. X plus 2 can't go any further. X squared minus 9, no, I see some perfect squares. So x squared minus 9 splits up into x and x. 9 is 3 times 3. One parenthesis is plus, one's a minus. Bring down that x plus 2 that we did when we did the grouping because it's part of my final answer. And so there would be your final answer. Let's do one more like that. This next one, let's group. Between 4x cubed and 12x squared, I can take out a 4x squared. So I'm going to have an x plus a 3 left. Again, I have a minus, and so I'm going to take him out, and then the 9 will go into both 9x and 27, so I'm going to divide by negative 9. I'm going to write that so you can actually see the signs. So that gives me an x. Negative 27 divided by negative 9 gives me positive 3. My parentheses match. So I have x plus 3. I have 4x squared minus 9. And then that's the parentheses that can go further because 4 is 2 times 2. 9 is 3 times 3. And I have an x squared. So I'm going to have a 2x, a 2x, a 3, and a 3. One's a plus, one's a minus. Bring down that x plus 3. Okay, I'm going to do another kind. I'm going to do just a few of these because these are trinomials, and really and truly, I have you do trinomials using the AC method. So this trinomial, I would expect you to do the AC method, but it's also something called a perfect square trinomial, meaning my first term is a perfect square, my last term is a perfect square, and you can try, there's a way to factor those perfect squares, but you always have to check it and make sure to FOIL it back to make sure you get the 12x, in this case, in the middle. The way you would do that with trinomials, 4x squared is 2x and 2x. 9 is 3 times 3. Since everything is positive, the parentheses would both be positive. Then I would need to FOIL it back. 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is another 6x. That gives me 12x. Last times last is 3 times 3, which is 9. So that works. You could also write it as 2x plus 3 squared. But now I really expect you to use the AC method on this one. And I'll show you on the next page. Again, the AC method works on these. Because if I do AC method, 25 times 9 is 225. The factors of 225 that add up to 30 are 15 and 15. What ends up happening is your factors that add up to the middle term end up being the same number. So if I were doing this with AC method, then I would go 25x squared plus 15x plus another 15x plus 9. And then we're going to go to grouping because I've got 4 terms. In that first group, I can take out a 5x. So that's going to leave me 5x plus 3. In the second one, I can take out a 3. So I'm going to take out a 3, and that's going to leave me 5x plus 3. So see, in perfect square trinomials, you end up with the same parentheses. So 5x plus 3 bring down. The GCFs I took out were also 5x plus 3. So you can see you end up with the same exact parentheses on those. Now these higher order ones we're not worried about in this course, so I'm not going to worry about those higher order ones. Just be sure you factor completely when you're doing these, and make sure you don't have a squared left in your final answer. And that's it for factoring squares and a little bit of perfect square trinomials. Y'all have a wonderful day.